At 7:10 in the morning, on a humid July day in 1943, the Lake City Ordnance Plant outside Independence, Missouri, was already shaking under the weight of its own machines. Rows of stamping presses hammered brass into cartridge cups. Heat radiated from annealing furnaces. Conveyor belts clattered in mechanical chorus. The air carried a metallic smell mixed with oil and sweat. America needed ammunition at a scale no nation had ever attempted. Combat commanders in the Solomons reported burning through hundreds of thousands of rounds in a single week. Infantry units in Sicily demanded more. Fighter squadrons over Europe emptied their 50 caliber belts so fast that ordnance officers joked it took more ammunition to keep a B-17 in the air than to build one. The need was bottomless. The math was unforgiving. Washington estimated that to sustain simultaneous operations in the Pacific and the Mediterranean, the United States needed roughly 2.4 billion rounds every month. Actual output at that moment was barely half. Inside the factory, 19-year-old Evelyn Carter pushed her cart of brass casings toward Line 4 and tried not to think about the numbers. Workers whispered about it during coffee breaks. 200 combat reports said the same thing. Frontline units were rationing ammunition, not because of supply lines, but because America simply wasn't making enough. Evelyn had started here only 12 weeks earlier, but even she understood the gravity. She watched supervisors frown at production charts pinned to clipboards. She overheard engineers muttering about bottlenecks. She noticed something else, too. Something the foreman seemed almost afraid to admit. The most delicate part of the operation, the moment where raw casings had to be fed into alignment tracks before charging and crimping, was still done by human hands, working in a repetitive pattern that hadn't changed since 1918. By 7:20, a new shift had settled in. 6 women gathered at the feeder table, arms moving in tight loops. Pick, place, slide, pick, place, slide. 3 motions repeated thousands of times each hour. The plant hoped for 30,000 fed casings every hour on this line. On most days, it stalled at 23,000. The difference, when scaled across the entire facility, meant millions of missing rounds every 24 hours. 1 broken fingernail, 1 slip, 1 jammed guide rail, and the entire sequence froze. Evelyn learned quickly that the real enemy inside a wartime plant wasn't sabotage or defective metal. It was seconds, lost seconds. At 7:26, a guide rail snapped loose. Casings scattered across the floor. Production stopped. A red warning lamp flashed overhead. Supervisors sprinted in. Mechanics pushed carts. The women stepped back, wiping sweat from their foreheads. They knew the drill. Every stoppage meant recalibration. Every recalibration meant lost output. Somewhere in the Pacific, a Marine machine gun crew was firing faster than Lake City could replenish. Evelyn knelt, gathering the spilled casings, and something odd tugged at her attention. The pattern of the women's hands, the rhythm, the looping motion of wrists and shoulders. It was circular, predictable, mechanical in its own way. She hesitated, watching the motion repeat as the workers resumed. Pick, place, slide, an orbit rather than a line. She should have returned to her cart. Instead, she found herself staring, trying to place the familiarity of the motion. It was on the tip of her mind, a memory from a high school history textbook, or maybe a museum trip with her father. A machine that spun to feed something faster than human hands could ever manage. She tried to shake the thought off. It was absurd. She was no engineer, just a teenager earning 80 cents an hour. And yet, the idea wouldn't leave. A rotating pattern, multiple stations sharing the load, a circular platform that moved items from hand to hand, something that fed endlessly as long as the wheel kept turning. At 7:34, the line resumed at a crawl. Evelyn glanced up at the production clock and felt a tightening in her chest. Another 10 minutes lost, another chunk missing from the daily quota. Somewhere in Washington, a colonel would underline the number in red and call Lake City for explanations. She rose, dusted off her hands, and wheeled her cart down the aisle. But as she walked, the thought came back sharper this time. A rotating system could eliminate the start-stop rhythm of human motion. A wheel, not a line. A ring of feeders instead of a row. Efficiency gained not by forcing workers to move faster, but by letting the machine carry the motion for them. The shape formed in her mind so suddenly that she stopped in the middle of the aisle. A wheel, a drum, a rotating star of loading slots, like a... No, that was ridiculous. But it wasn't. She remembered the name now. Gatling! The old multi-barreled gun from the Civil War that increased firing rate by rotating barrels instead of demanding one barrel cool down. What if feeding ammunition worked the same way, in reverse? What if rotation could solve the bottleneck that linear motion couldn't? It was a foolish comparison, she told herself, and yet the idea pulsed with a strange clarity. As she pushed through the heat toward the rear of the factory, she felt the oddest sensation, not inspiration exactly, more like inevitability, as though the solution had been sitting in plain sight, and she had simply tripped over it. And if she was right, even a modest improvement might ripple outward across the entire plant. A handful of seconds saved at each station, a handful multiplied by hundreds of workers, scaled across 12 lines, scaled across 24 hours. The numbers could climb quickly, maybe dangerously quickly. What she didn't know yet was how that small observation, born in the middle of a jammed assembly line at 7:26, would grow into a mechanism capable of doubling Lake City's daily output, or how its influence would stretch far beyond Missouri, all the way to Normandy, Saipan, and the skies over Europe. For now, all she had was a half-formed idea she barely understood. But ideas, even fragile ones, shape wars more than we admit. Before we go further, I want to know what you think. If you believe, like I do, that the smallest observations often create the largest shifts in history, comment the number 7. If you disagree, tap like. And if you want to see how this idea turns into a machine that changed America's war output, subscribe so you don't miss the next chapter. At 8 o'clock hours, the plant whistle screamed again, a long metallic blast that rattled the sheet metal walls and signaled the official start of the day shift. The night crew shuffled out with the hollow-eyed look of people who had moved brass, oil, and steel through their hands for 14 hours straight. The day crew moved in, stepping around bins of warm casings that still emitted a copper smell. A clipboard hung near the entrance with the morning numbers, handwritten in pencil. Units short. Again, the deficit looked small on paper, tens of thousands of rounds, but scaled across 24 hours, scaled across the coming invasions, scaled across 2 oceans. Those missing rounds turned into something far heavier. Commanders in Europe were reporting firefights where American platoons nearly went black on ammunition. Marine machine gun crews at Munda burned through belts faster than transports could deliver them. The Army's own quartermaster analysis predicted that if output didn't rise by at least 20% by autumn, entire offensives might stall, not for lack of tanks, not for lack of planes, for lack of bullets. By 8:07, the heat had climbed past what most offices would consider survivable. Lake City had been designed for production, not comfort. Long glass windows caught the morning sun and turned the place into a convection chamber. Furnaces warmed the annealing rooms. Steam rose from coolant baths. Workers wore cotton headbands to keep sweat out of their eyes, but it didn't help much. Supervisors carried pocket thermometers that routinely showed temperatures pushing 97 degrees. The human body adapted out of necessity, not preference. No one complained. Complaining didn't add brass to the belts. Complaining didn't move the war a minute closer to ending. Evelyn pushed her cart toward the main floor and watched the rhythmic sway of moving belts, the endless rattle of trays feeding casings into crimping dies. Between the noise, the vibration, and the motion, the plant felt alive, restless, almost predatory. America was fighting a war of distance, a war that demanded material over finesse, tonnage over elegance. To take a single island in the Pacific, gunners might fire 500,000 rounds. Destroyer escorts in the Atlantic burned thousands in a single night engagement. A flight of P-47 Thunderbolts, those same aircraft that devoured 50 caliber ammunition during bomber escort missions, could empty entire belts in mere seconds. Multiply that by all the squadrons in England, North Africa, the Central Pacific, and the numbers curled upward like smoke. The math was merciless. The front line would always demand more than the factories could comfortably supply. At 8:13, a foreman in a sweat-darkened shirt unlocked a metal cabinet and pulled out the previous day's production summary. The line graphs were brutal. Lake City had managed a monthly high of roughly 1.4 billion rounds. For the war planners in Washington, that wasn't just insufficient. It was a crisis. Reports arriving from Sicily said infantry companies were reducing training fire allotments because they feared they wouldn't have enough for combat. In the Solomons, platoon leaders wrote home asking families to petition representatives for more ammunition. It sounded absurd, almost melodramatic, but those letters existed. Evelyn had seen photocopies posted on the bulletin board as motivational reminders. A Marine sergeant had scribbled, "We're running the guns hot enough to melt the jackets. Send more." She paused near line 6 as an inspector checked casing dimensions with a micrometer. 12 thousandths of an inch too wide, and the round jammed. 6 thousandths too narrow, and it failed pressure tests. Precision mattered, and precision took time. Time America didn't have. And yet, Evelyn thought, even precision wasn't the real monster here. The real monster was throughput. 1,000 of anything was achievable. 1 million was a challenge. 1 billion per month was something else entirely. By 8:25, the morning briefing began. A lieutenant from the Ordnance Department read from a typed memo delivered straight from Washington. Consumption rates across all commands had risen by nearly 30%. Enemy resistance was intensifying. More artillery duels, more close-in firefights, more aerial intercepts. Ammunition was disappearing faster than wartime planners had predicted in 1942. The numbers on the chart looked almost fictional. To support projected operations in Burma, Italy, the Marshalls, and soon, inevitably, France, Ordnance plants needed to raise output past 2.4 billion rounds monthly. The lieutenant didn't sugarcoat the truth. Failure here meant failure everywhere else. Evelyn listened, shoulders tensing as he continued. The margin between enough and catastrophe often came down to minutes. 10 minutes lost to a jammed conveyor might not seem disastrous inside the plant, but 10 minutes multiplied across 12 lines, multiplied across 2 shifts, multiplied across a 30-day cycle meant hundreds of thousands of rounds simply never existed. And hundreds of thousands mattered. They were firefights, won or lost, hills taken or abandoned, lives protected or spent. She caught herself imagining what a single percentage point of efficiency might look like at scale. A 1% improvement meant roughly 14 million additional rounds per month. A 5% improvement meant 70 million. Numbers so large they barely made sense. Yet the war ran on them. Logistics officers in the Pacific measured battles not in miles gained, but in tonnage delivered. Aerial commanders calculated sorties by gallons of fuel and belts of ammunition. Behind every frontline success was the quiet hum of places like Lake City, places where 19-year-olds like her pushed carts of brass under ceilings that dripped with condensation. At 8:33, the briefing ended. The workers scattered back to their stations. Evelyn hesitated, feeling something she couldn't quite name. Responsibility, maybe, or the faint pressure of a realization forming just outside her awareness. She wasn't an engineer or a scientist. She had no authority, no title, but she did have eyes. She had noticed patterns others hadn't. She kept replaying the looping motion of the feeders from earlier that morning, that circular rhythm, that forgotten memory of a rotating gun mechanism. She felt it again. The sense that the difference between shortage and surplus might not be a matter of heroic breakthroughs, but of the smallest, simplest shift in process. Before moving on, I want to hear your perspective. If you believe, as I do, that wars are shaped more by production numbers than battlefield tactics, comment the number 7. If you disagree, hit like and stay with this story, because the moment where Evelyn's observation turns into something real is coming, and it changes everything. Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the At 9:11 that morning, after the briefing dissolved into the usual thunder of machinery, Evelyn stood beside Line 4 again and felt the strange insistence of the idea that had been tugging at her since dawn. It pressed at her like a half-remembered dream, something obvious and ridiculous at the same time. The line was running, but limping, the workers' motions precise, yet strained. 6 pairs of hands repeating the same circular path, the same choreography of fatigue, reach, lift, set, withdraw, over and over. A loop disguised as a line. She watched for several seconds without blinking, letting the rhythm imprint itself. Then her breath caught, not because she understood the solution fully, but because she suddenly saw the shape, a wheel, a rotating carrier, a principle that had existed for nearly 80 years, yet no one here seemed to notice. At 9:14, an inspector walked by, muttering about throughput again. A missed quota yesterday, another looming today. No one asked why the numbers always lagged. No one questioned whether the bottleneck was built into the process itself. They simply tried harder. More hands, longer shifts, more pressure. Evelyn wiped her palms on her apron and felt a small pulse of defiance. Trying harder wasn't going to get Lake City from 1.4 billion rounds to 2 billion per month. Doing the same thing faster didn't change the math. Changing the motion might. She slipped away from the line when the foreman turned his back and walked toward a scrap bin near the east wall. It was filled with broken pallets, bent metal brackets, discarded wooden slats, a dozen objects whose purpose had been forgotten. She picked through the pile, feeling the coarse grain of old pine boards, the rough ends of cut dowels, the cold rim of a discarded bearing ring. She didn't know exactly what she needed, but she knew she needed something circular, something that could turn without binding, something that could carry weight but not collapse under vibration. The moment she touched the bearing ring, still oily despite months of neglect, she felt a spark of recognition. A wheel needed a heart. This could be it. At 9:23, she ducked behind a stack of crates near the maintenance shed and began assembling a rough outline on the concrete floor. She arranged 3 wooden slats in a triangle, then 6 in a star, then 8. She tested how the slats might rotate around the bearing ring, trying to visualize ammunition casings sitting in small recesses along the edges. Her fingers trembled from the absurdity of the attempt. She wasn't supposed to be here. She wasn't supposed to be inventing anything. She wasn't even supposed to be away from the feeder station, but the urgency of the idea overpowered any concern for protocol. Time was bleeding away, and so were rounds. She had felt the weight of that deficit all morning. At 9:31, a mechanic emerged from the maintenance shed and froze when he saw her kneeling on the floor with a ring and stray lumber arranged in a strange geometric pattern. He raised an eyebrow. She blurted out an explanation, one she didn't fully understand herself. A conveyor that rotated, a circular motion that redistributed load, a pattern inspired by a multi-barreled gun whose name escaped her at that moment. The mechanic listened, skeptical but amused. Then he surprised her. He didn't laugh. Instead, he asked quietly, "What problem are you actually trying to solve?" And when she answered, "Throughput," he nodded. Throughput was a language everyone at Lake City spoke. At 9:37, she tried rotating the improvised star by hand. It wobbled. The slats were uneven. The bearing ring slipped free. It didn't matter. The purpose of the exercise wasn't to build the final version. It was to confirm the principle: rotational transfer instead of linear transfer, a wheel instead of a conveyor belt, multiple feeders instead of one, each rotation delivering a fresh set of casings to the alignment channels without forcing human hands into the tight, repetitive, wrist-destroying pattern that caused jams. She measured the approximate diameter with her forearm. 26 inches, maybe 28. Big enough to carry 3 trays at once, small enough to fit on the existing framework. At 9:42, she went to the small drafting table near the supervisor's office and drew the rough design with a stub of dull pencil, a central ring, a rotating plate, peripheral slots angled to cradle casings, a mechanical linkage connecting the rotation to the existing conveyor belt motor. She didn't know the torque requirements or the exact alignment specs, but she knew the most important variable, frequency. If the wheel rotated 9 times per minute, each revolution could feed roughly 1,000 casings. Multiply by 60 minutes, and the line could exceed 60,000 units per hour. Multiply by 4 wheels per line, and the number ballooned again. Evelyn blinked, startled by her own calculations. Even with modest accuracy, this would produce gains that supervisors had been begging for since spring. At 9:50, the foreman found her and demanded an explanation for why she wasn't at her station. She held the paper up, her voice trembling as she explained the concept. A rotating feeder, like a Gatling gun, but inverted. The foreman stared at her, then at the sketch, then back at her with a look she couldn't decipher. He didn't dismiss her. He didn't scold her. He simply said they would test the model during lunch break, not because he believed it would work, but because desperation had a way of opening doors that were usually sealed shut. At 9:58, she returned to her line, hands shaking, mind racing. The machine noise seemed louder now, the rhythm of the feeders more urgent, more fragile. She watched the workers move through their loops and felt a surreal moment of distance, as though she were seeing the process through different eyes. She wasn't imagining the bottleneck anymore. She was diagnosing it, even if her wheel failed, even if the mechanics laughed her out of the building, even if the plant reverted to old habits. She had crossed an invisible threshold. Once you see the inefficiency in a system, you cannot unsee it. At 11:22, under the sour smell of coolant and brass dust, the maintenance crew cleared a narrow space beside Line 2 for the test. They did not shut the line down. No one would dare risk the quota for an experiment dreamed up by a 19-year-old with a sketch on scrap paper. They simply carved out a pocket of floor where a small wooden mock-up could spin without injuring anyone if it shattered. A half-circle of workers gathered, some curious, some skeptical, all exhausted. The foreman glanced at his watch. The test had exactly 3 minutes, not 4, not 5. Lunch break wasn't until noon, and the war did not pause to indulge ideas. At 11:23, Evelyn set the crude wooden wheel onto a temporary spindle the mechanic had bolted to a bench. The wheel wobbled before it even turned. The slats were uneven, the bearing ring too loose, but it didn't matter. This was not a prototype. This was proof of motion. The mechanic attached a small belt from a discarded motor. He flicked the switch. The wheel jerked, hesitated, then spun with a trembling, jittery rhythm. Evelyn placed 3 casings into the shallow recesses she had carved with a pocket knife. The wheel rotated. One casing fell correctly into the alignment channel. Another bounced out. The third shot across the bench and clattered onto the concrete floor. Spinning like a doomed coin, the workers burst into laughter. Not cruel, just tired, just honest. The wheel was too light, too fast, too uneven. It scattered metal like a toddler tossing marbles. The foreman shook his head and restarted the stopwatch. 2 minutes left. Evelyn swallowed hard, cheeks burning. She adjusted the recesses with her thumb. She slowed the motor by tightening the belt. The second rotation delivered 1 casing properly, and 1 half jammed. The third bounced out entirely. A pattern was emerging, but not the one she had hoped for. The idea wasn't wrong. The build was, and even as failure loomed, she understood that this moment, was where most ideas died. Not because they were impossible, because the first attempt embarrassed the creator. At 11:25, the foreman said time was up, but something unexpected happened. The mechanic who had helped her earlier stepped forward and said, "Wait, 1 more rotation." The foreman let the clock run. The mechanic steadied the wheel with both hands, adjusting the tension, lowering the speed until the rotation resembled the slow, methodical sweep of a lighthouse beam. Evelyn placed 3 more casings. The wheel turned. One casing fed cleanly. The second slid halfway, but corrected itself at the guide lip. The third wobbled, but fell exactly where it needed to. A small ripple of surprise moved through the circle of workers. It wasn't success, not yet, but it was motion that made sense, motion that could be refined. At 11:26, the foreman cut power. The crowd dispersed. The moment ended. The line roared on, drowning the faint echo of Evelyn's heartbeat. She helped sweep up the spilled casings, but her mind was far away, racing through variables she barely understood. Depth of recess, angle of approach, damping material, rotational frequency. She felt the strange high of failure that carries instruction, not discouragement. Yet when she returned to her cart, her hands trembled. The embarrassment lingered. She imagined supervisors mocking her. She imagined engineers dismissing the idea with a single sentence. If it were useful, someone would have built it already. At 11:35, an older woman from Line 4 approached her quietly, the same woman who had been working the feeder table that morning. She said nothing at first. She simply set a casing into Evelyn's hand and pointed at the faint dent along its rim. "You see that?" she asked. "That's from fatigue. Repetition does that. To metal, to people." She looked toward the wooden wheel, still sitting crooked on the bench. "Anything that reduces that repetition is worth trying." Evelyn nodded, too stunned to speak. She had expected ridicule. She had not expected encouragement. At 11:42, Evelyn slipped away again with her sketch. She sat beside the empty loading dock and began redrawing the design. Deeper recesses, rubber lining for grip, a weight ring to stabilize rotation, a metal spindle instead of wood. She recalculated the revolutions per minute. She wrote numbers in the margins, crossing them out, rewriting them. Every assumption bent and warped as she tried to imagine a device rugged enough to survive Lake City's relentless vibration. And then something shifted. She added a second wheel beside the first, then a third, a staggered rotation, a synchronized triple feed. A system that could act like a mechanical heartbeat, one wheel feeding casings while another reloaded itself. Continuous motion instead of start-stop drudgery. Her pulse quickened. The idea was evolving, expanding into something with weight and teeth. At 11:58, the lunch whistle blew. Workers flooded toward the cafeteria. Evelyn stood, stretched her aching legs, and stared once again at the factory floor. The lines moved with their usual halting rhythm. The bottleneck remained, and yet she sensed the tiniest tilt in the air. The mechanic had seen possibility. The older woman had seen necessity. The foreman hadn't rejected her outright. Failure had not killed the idea. It had revealed its weak points. She walked back toward Line 2, passing the wooden wheel. It looked pitiful now, fragile and uneven. But she felt a flicker of respect for it. The first draft of anything is a ghost. It exists only to be replaced by its stronger descendant. At 12:47, long after most workers had returned from lunch and the heat inside the plant had crept back into the unbearable range, the foreman called Evelyn to the supervisor's platform overlooking the main assembly hall. She climbed the metal stairs with the uneasy feeling of someone expecting reprimand, not recognition. Below her, the plant roared with its usual chaos, presses hammering brass into cups, cooling fans screaming over the furnaces, belts clattering under the weight of half-finished rounds. But on the platform stood three people who did not belong to the routine of Lake City. a procurement officer from the Ordnance Department, a plant engineer with grease still on his sleeves, and the mechanic who had helped her steady the shaky wooden wheel. All three were staring at her sketch, spread out across the supervisor's desk and weighted down with brass casings. At 12:49, the engineer asked her to explain the concept again. She tried, stumbling at first, then finding her rhythm. Rotational feed reduced manual transfer, a system that redistributes work across a circular motion rather than a linear one. She pointed to her revised drawing with hands that trembled from equal parts fear and adrenaline. The engineer listened without interrupting, which unnerved her even more. When she finished, he tapped the margin where she had added a second wheel. He asked why. She answered honestly, because one wheel could feed continuously only if the next one was already reloading itself. A staggered rotation meant no empty cycles, no pauses, no dead time. At 12:54, he exchanged a quick glance with the procurement officer, then asked for production numbers, not the plant's numbers, hers, the ones she had scribbled in pencil. She braced for dismissal. Instead, he nodded slowly. Her math was not exact, but it wasn't fantasy either. If a full system ran at 9 revolutions per minute, with 6 slots per wheel, and if 3 wheels were synchronized, the theoretical throughput approached 100,000 casings per hour. The engineer's voice flattened into something she had never heard from him before, something like respect. Not belief, not yet, but respect for the logic. Even flawed logic can reveal a path worth testing. At 1300 hours, the procurement officer made a decision Evelyn would only understand fully months later. He authorized the maintenance crew to build a steel prototype during the night shift, not a production version, just a test rig, something that could spin without disintegrating, something strong enough to hold real ammunition casings without scattering them across the floor. A test model that could answer the question no one wanted to ask aloud. Could a 19-year-old factory worker actually solve the bottleneck that had haunted Lake City for over a year? At 1308, the rumor reached the assembly floor. Workers leaned over machines to whisper. Supervisors exchanged clipped sentences. The idea of a rotating conveyor was not entirely new. Factories had experimented with partial rotations before, but a multi-wheel synchronized feed was something else, something untested, something improbable, something that, if it worked, might just push Lake City toward the impossible quota Washington demanded. The women on Line 4 gave Evelyn quick glances that mixed pride with worry. Pride that someone from the line had gotten this far. Worry that failure would come down harder on a girl than on an engineer. At 1316, the plant engineer met with line supervisors. He unrolled the blueprint Evelyn had drawn and translated it into engineering language. Stabilized central spindle, weighted perimeter ring, rubber-lined recesses for noise and vibration suppression, incremental feed into existing alignment channels, gear reduction to control rotational speed. The supervisors stared, trying to picture the motion. One finally asked the question they were all thinking. What if it jams? The engineer answered with a sentence that stuck in Evelyn's memory for years. If it jams, we fix it. If it works, we rewrite the rulebook. At 1327, as if to underline the urgency, Line 6 choked again, a jammed guide rail. Half a dozen workers swarmed in, clearing the obstruction, losing another 7 minutes. 7 minutes meant nearly 4,000 casings lost. 4,000 rounds, meant an entire rifle platoon hollowed out during training or combat. And so, the idea of trying something, anything new, began to shift from curiosity to necessity. At 1332, the mechanic handed Evelyn a scrap of steel plate. He told her the prototype would be built tonight, but if she had adjustments to the design, she needed to make them now. He wasn't patronizing her. He was inviting her into the process. She took the steel and the newfound responsibility simultaneously, feeling the weight of both. She revised the angle of the recesses, deepened the curvature, adjusted the alignment lip. She could not calculate engineering tolerances, but she understood the physics of human motion and how the current system exhausted the workers. The design didn't need to be perfect. It needed to relieve that exhaustion. Throughput wasn't just numbers. Throughput was endurance. At 1345, the procurement officer called headquarters. A short call, a simple message. Potential improvement in feeder efficiency under evaluation. No mention of who suggested it. No mention of the girl who spent her breaks sketching rotational diagrams on packing paper. That anonymity might have frustrated someone older, but for Evelyn it felt like protection. Failure would not ruin her name. Success would, perhaps, reveal it. At 1352, the foreman gathered the workers and gave them an unusual instruction. For the rest of the shift, observe your hands. Observe the rhythm. Observe the fatigue. He did not explain why. He did not mention the wheel. But he understood something crucial. Innovation lands hardest on those expected to use it. If the workers saw the flaw in the old system, they would embrace the new one without a fight. By 1400 hours, the shift settled into its usual grind. But something intangible had changed. Possibility had entered the building. If you enjoy dramatic, jaw-dropping stories, subscribe to WW2 Archives Declassified. Let's grow this channel to 1,000 subscribers. At 6:50 the following morning, the plant whistle tore through the pre-dawn stillness as workers streamed toward the entrance with their usual fatigue-dulled expressions. None of them knew that the steel prototype built during the night shift now sat bolted to Line 2's framework, waiting to prove or destroy everything Evelyn had imagined. The foreman stood beside it, arms crossed, face unreadable. He had seen 1,000 promising ideas collapse under the weight of real production. He had watched engineers bring blueprints that looked flawless on paper, but disintegrated within minutes of contact with heat, vibration, and human error. This wheel, crude, heavy, overbuilt, did not inspire confidence at first glance. But it inspired something else, necessity. At 0658, the engineer opened the motor housing and verified the gear ratio one final time. 9 revolutions per minute, no more, no less. He glanced at Evelyn, who stood several feet back, hands clenched so tightly her knuckles had gone pale. Then he nodded to the mechanic. Power. At 0700, the switch snapped. The motor hummed, the wheel stirred, hesitated for half a rotation, then found its rhythm. A slow, deliberate turning, steady as a clock hand, methodical as breathing. The first worker stepped forward and fed casings onto the recesses. The wheel carried them forward without complaint. No wobble, no scatter, no hesitation. One by one, the casings reached the alignment chute and dropped cleanly into place. The rhythm was hypnotic, unnatural in its consistency. At 0703, the line hit its first full operational minute. The typical feed rate at this station hovered around 380 casings per minute on a good day. The counter ticked past 600, then 680, then 740. Workers leaned closer, squinting at the numbers as if the gauge had malfunctioned. But the sound told the truth before the numbers did. The alignment channels rattled faster. The conveyor belt hummed with a different urgency. The entire line seemed to exhale, as if someone had loosened a knot that had been choking it for months. At 0709, the foreman allowed himself the smallest flicker of something that might have been hope. He had spent a year watching this plant bleed seconds, a year listening to Washington demand miracles, a year knowing that no amount of effort could compensate for a flawed process. Now, for the first time, the process itself had changed. At 0715, they ran a full 10-minute test with no interruptions. The wheel absorbed the load without protest. The rubber lining dampened vibration. The weighted rim stabilized rotation. Casings fell with metronomic precision that felt almost impossible. When the counter stopped, the room went silent. 82,000 casings per hour. Not 23,000, not 30,000, 82,000, nearly triple the baseline. At 0721, the plant engineer stared at the numbers, recalculating in his head, searching for the error that had to exist. But there was no error, just a wheel turning, just a rhythm that finally matched the urgency of war. Evelyn stood motionless, barely breathing, feeling the floor vibrate beneath her boots, not from chaos, but from efficiency. Throughput wasn't just a number anymore. It was motion made visible. At 0728, the superintendent arrived, summoned by the foreman's clipped message. He studied the wheel, the counter, the absence of jams. Then he looked at Evelyn, and for the first time, someone in authority saw her not as a girl with a sketch, but as the architect of something undeniable. At 0945, 3 hours after the wheel proved itself on line 2, the superintendent made a decision that would ripple far beyond the walls of Lake City. He authorized immediate fabrication of 11 additional units, full conversion of line 2 by end of week, phased installation across lines 3, 4, and 6 within 30 days. No speeches, no celebration. Just a signature on a requisition form and a terse instruction to the machine shop. Priority above all other projects. The war did not pause for recognition ceremonies. At 10:18, a memo left the plant on official Ordnance Department letterhead. It was 3 sentences long. Feeder efficiency improvement achieved at Lake City. Throughput increase of 250% demonstrated under live production conditions. Request authorization for plant-wide implementation. No mention of Evelyn Carter. No mention of wooden prototypes or lunch break sketches or a 19-year-old girl who saw what engineers had missed. Just numbers. In Washington, numbers were the only language that mattered. By 1100 hours, the plant engineer gathered the maintenance crews and translated Evelyn's design into formal engineering specifications. Drawings were redrawn with proper tolerances, materials lists were compiled, installation sequences were mapped. The crude prototype became a blueprint. The blueprint became a system. Innovation, once proven, moved with terrifying speed. At 12:47, the first of the new wheels was already taking shape in the machine shop. Steel cut, spindles turned, rubber sourced from a supplier in Kansas City who promised delivery within 48 hours. Lake City had spent a year trapped at 1.4 billion rounds per month. Now, with synchronized rotating feeders across 12 lines, the projected output climbed toward 2.2 billion. still short of Washington's demand, but no longer impossible. At 15:20, Evelyn returned to her station on Line 4, pushing her cart of casings with the same steady rhythm she had maintained for 12 weeks. Nothing had changed for her. No promotion, no commendation, no acknowledgment beyond a brief nod from the foreman. But she felt the difference in the air, the way the plant breathed easier, the way workers moved with slightly less exhaustion, the way the counters ticked faster without the brittle urgency of desperation. Throughput was no longer a crisis. It was simply motion. At 1600 hours, as the day shift prepared to end, a Marine Corps logistics officer in the Solomon Islands received a revised ammunition allotment. He did not know why. He did not know about Missouri or rotating wheels or a girl named Evelyn Carter. He only knew that for the first time in 4 months his supply request had been approved in full. Somewhere in the vast machinery of war, a bottleneck had cleared. At 1843, as darkness settled over Lake City and the night shift took over, the wheels continued turning, 9 revolutions per minute. Steady, relentless, unnoticed by anyone except those who understood what they represented. Not genius, not heroism, just observation turned into action, fatigue turned into efficiency, seconds reclaimed and multiplied into millions. Wars are not won by single moments. They are won by the accumulation of small corrections, invisible to history, but decisive in outcome. Evelyn Carter never received a medal. Her name never appeared in after-action reports or presidential speeches. But in the summer of 1944, when Allied forces stormed the beaches of Normandy with enough ammunition to sustain the longest day of the war, some of those rounds were fed through wheels she had imagined on a humid July morning while watching hands move in circles. History remembers generals and battles, but wars are shaped by those who see the inefficiency in a system and refuse to look away. Don't just watch, subscribe. Help. Archives. Declassified hit 1,000 subscribers.